The broadcast is now starting. All attendees are in listen-only mode.
Hello, and thank you for joining today's Manufacturing Power Hour, Understanding the Inventor Drawing Environment. Hello, my name is Don Warner. A little bit about M2 Technologies. M2 Technologies is a consulting firm focused on productivity, improving manufacturing process efficiency, and reducing manufacturing costs. Using generative design and best-in-class manufacturing, along with asset management processes, our team of industry experts can help you become more sustainable, more profitable, more prepared to meet today's urbanization in a rapidly changing world. What we do, and yet not limited to, is mostly BIM for manufacturing, some asset management, process optimization, and data management. We're also an industry-leading partner with Autodesk as a gold partner. We're a Panzora partner. We're an Eagle Point Pinnacle partner, and we're a Bluebeam partner. Our services are limited to, but not all of here are listed: CAD management, software development, data management, product lifecycle management, CAM training and standard development, just to name a few. A little bit about myself. Hello again, my name is Don Warner. I'm an application engineer here, 30 years experience in the CAD and design field, 10 years with an Autodesk partner, AE. I also worked for Autodesk product support for 13 years, and I was also a manufacturing designer for 7 years prior to that. Today's agenda will review drawing view options. We'll review the dimensioning tools to document a file. We'll also review the other annotation tools to document files. We'll learn about retrieving dimensions from models, understanding the title box and borders, and the last we'll review sketch symbols. What I'd first like to talk to you about is the basic view types that the drawing environment allows you to create once you have finished creating your 3D model, whether it's an assembly or a part file. The basic commands that are available to you is the base view, which is the first view you will create. Then from that view, you can project views, which is the one underneath. These are orthographic and isometric views depending on the angle of your cursor in reference to the base view location. You can also create auxiliary views. If there was a projected line or an edge that you want to show a view at a certain perpendicularity from that line or edge, the auxiliary view is an option. You can also create section views. What section view will have you do is create a sketch inside the view that will control what we call the cutting lines. This is also options for part and assembly file. You can create a detail view, which is an enlarged view of the base view or projected view. There's an overlay view. This really comes into position when you have assembly views and you need to have, say, a top position, a middle position, and a bottom position. You can overlay views on top of each other to show those different orientations. And then there's a separate draft view you can create, which is something that is not referencing the model information. It is simply a 2D sketch inside the IDW or DWG file. In this slide, I just wanted to show you some reference images of those different views. As you can see, the base view up the top, there is a green square that outlines the base view, and to the right or the left of that base view are the projected views. You also can see the projected view on the upper right also. The auxiliary view, as again, it's kind of an example from this little block that has a countersunk hole or a slot inside of it. they're using the edge of the hidden line to create the auxiliary view. Next would be section views. This is where you can control a sketched line. The sketch line represents the cutting plane. And once you establish that cutting plane, the next procedural step will be just to place the section view. Down the bottom is a reference of the detail view. You can simply draw a circle around the area you want to explode or scale up. And there's also overlay views showing the suspension part of a race car in the assembly mode. When you get into creating the drawing views itself, there will be a drawing view tab that is presented to you. Within this dialog box, you do have 4 separate tabs that you can make selections in. The first tab is the component tab. What this will allow you to do is choose from the available files you have open within the Inventor software application at that time. Or if the file is not open, you simply have a browse button that allows you to go out and scan the directory to where that file is, that you can go ahead and create a view. Underneath the file options, there is a representation view. If you were to have created representation views inside your part or your assembly file, it's more common in the assembly file. But if you've done it in either or, you can go ahead and reference that view, the representation view that you have in the model, to be depicted in the view to be generated. Over in the area where there is the style, you have different options. You can choose a style where you show the hidden lines. You can also turn off the hidden lines, or you could show the part in a shaded view. Most of the time that's used for the isometrics, while the base and auxiliary views are either shown with hidden lines on or off. The raster view option is simply a speed option. If you had for example, a large assembly file that took a long time for that view to generate, if you check on the raster view, what happens is it takes basically a snapshot of what it thinks the view will look like, and it quickly puts the raster view on. At a later time, you can edit the view, you can uncheck the raster, and it will go ahead and start to do the calculations and complete the view as normal. And there's also label options down the bottom where you can choose the view and scale type. Down the bottom is a series of the different tabs. The model tab. This is really only used if the part file that you are creating the view happens to be an iPart. I don't really have any information around what an iPart is, but in general, it is a version of a part. If you could think of maybe a linkage arm that's in different lengths. Instead of drawing all these as individual part files, say you have 5 different lengths of these linkage arms, instead of drawing 5 individual parts, basically you create what we call an iPart, which is basic dimensions, and through a tabulated drawing or a tabulated area, you can choose the parametric dimensions to conform to the new part. That way it switched to version 1, 2, 3, 4, 5. And this is where you could basically select that iPart member. Going to the display options is where you can choose on basically whether you want to see the thread displays, whether you want to see tangent edges. There's also options down the bottom if you want to uncheck the align to base. At times you may not want to have views aligned to your base. There is also towards the right side of that dialog box, if it was an assembly view, there are options to control how your standard parts would look. And the last tab is the recovery options. It's not often used, but if your part includes some type of a surface models, whether it's assembly file, basically this is where you can turn on the settings to turn on the surface bodies to be displayed. Because when you create a drawing view, the lines that appear in that view are only generated from a 3D solid object. So if you do have any surface information in these files, it will not display by default when you go ahead and generate the views and place them. Going on to some more advanced drawing view options, there are views such as a break view. This will allow you to break the model in a way where you can see the left and right ends, per se, of a long linkage arm. Instead of scaling the view down to fit the object inside the border, this is where you can set a larger scale and basically break the view to show the left and right ends or the tops and bottoms, depending on how you want to manipulate the cut. There's also a breakout view, which allows you to see inside if you wanted to get ahead and show the internal guts of a part file or the assembly file. This is how you can use a sketched object on top of that view to use it as what we call a cutting planes to look inside. There's also a crop view. If there is maybe 15% of the view area that you want to really have retained, basically cropping the view will allow you to cut away the unnecessary geometry information you don't want in that view. There is also a slice option that produces a zero depth from any existing Inventor drawing view. What it basically will do is create a slice, almost taking a knife, and as you cut through the plane, it will show you the plane at that point. Some of the other options that are kind of unique is an exploded view. This is basically generated from a presentation file, which is different from the assembly or part file. This is where you would show the exploded view or how the assembled object would go together in an exploded view. And if you do work with sheet metal parts and you do create the flat patterns, the modeled flat patterns within the part file, when you create the DWG IDW file, you can select the drawing view and it will intelligently know that it's a sheet metal part that you have picked, and it will give you the option to create the flat pattern for that part file. And here's just some visual options of what I was just describing. As you can see, the break view is just basically shortening the long drawing views. The breakout views is a picture of some type of an engine, and you can actually get in there, and with the sketched objects, you can create a area of where you want to break in and create the cutaway. There's an example of the crop view, basically eliminating the geometry outside of the depicted window. And you can create slice views by picking between two sketch lines. There's a picture of a picture there where you can see they've created multiple slice lines through it. Down the bottom is the exploded view. And once again, this would be worked from a presentation file. And then the last item is the flat pattern file that you can generate. All right, I'll take a few minutes and just break away to my Inventor and show you the information I just explained. All right, what I'd like to do is just open a basic file here. It is a blank drawing border. But what I'm going to do is just go ahead over here to my base view. And again, you can see that I don't have any files open, so or any modeled files open. So this is why the documents here is blank. So I'll just go ahead and go to Browse, and I'll pick up my arm. I'll move the view over, and you can see it's going to basically try to depict a rough scale based on the drawing sheet. It's giving me a 1/4 scale, but if I decided to make this a 1:1 scale, you can just barely, I do not have the room I need if I wanted to show that at a full scale. So I can go ahead and just place the view there and say, okay, and create it. And this is where I could use the break view. And the break view is pretty straightforward. You go ahead, you come in here and you select the view you want. And then the next thing it's looking for is 2 blinds you want to pick. You know, if you had exact information in there, you could obviously use some sketch data, but basically by picking 2 points, you go ahead and create the break. And, you know, again, I'll come back over here. This is my first view, that's my base view. So if I decide to do a projected view, you could see that it's going to go ahead and create the breaks based on that. And if I just went ahead and put this in as a normal, you know, 1/4 scale that they had, again, I don't have a drawing open, so I got to go ahead and repick this. You can see by default, it's going to put it here, but if I come down and go inside this box, I can actually drag this out by left clicking and holding and placing it. So I just wanted to kind of show you by default. Once you place your 3 views by simply click, 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 you can right click and say okay, and it will generate the views. For example, here, as I was mentioning, these breakout view, the detail view, the section view, these all use sketched objects. For example, I'll go ahead and I'll say start sketch, and it immediately looks for a view it wants to assign that sketch to. So I'll go ahead and I'll pick up here, and for the sake of argument, I'm just going to draw a rectangle, and I'm going to say finish sketch. And if I come into the breakout view now, what it's looking for is the view, and it automatically finds the sketch that is associated with the view. And I'm gonna go in from that angle, or I should say from that face. I'm gonna go in a 1/2 inch. I know that part is 1 inch deep, and I'm gonna go from the point. And you got to pick a point. So I pick the top quadrant of anywhere along this object would have been fine. If I say okay, see how it automatically goes in and it sections the part. And you can see if I go off on my projection and put another ortho view in there, you can see that now I'm included that cut. So there's a lot of flexibility in here as far as what to do. And I don't have a lot of time, but these are just some of the examples of how these will work. I apologize, one other one, the section. It's kind of the same thing. If I wanted to start a sketch, let me see if I got a good one here. I'll delete this view here. And if I wanted to say up here, you could see that this is a top view, but if I decided to start a sketch on the top view and then I ran a line, you can see it picks the midpoint. So I'm just going to come out a little bit. I'm going to go straight through the part. I hit a return. You can see that I've got the sketched line in there now. If I choose a section, pick on the view, and now it's looking for, you know, I can use this as some geometry. Now you create your section view. So again, it's a combination of using sketches, assigning the sketch to the view, drawing the information that you want in there, and basically just, you know, finding a way to create what you need. There's a lot of flexibility in here, but that's just a little bit on some of the drawing view creations and options. Some of the other annotation tools is basically outside of your dimensions. You create your views, you put your views in there, you've documented how you want your part or assemblies to look. But now really what you want to do is go ahead and add dimensions to it. There's also some other information you can add, such as feature notes, such as hole and thread notes if you needed to add with a leader line. There's also text, straight out text. Most of the time, if you think of drawing notes, or you can create a bulleted list, numbered list of sorts. Symbols, this is a good thing if you could think about some common symbols, some geometric characteristics, material removal modifiers, some geometric tolerancing symbols, character map information. All this can be manipulated or brought in from the text dialog box, or you could more or less create sketch symbols. Be working with the text, you can generate, for example, a finished mark, and then you can put a piece of text in that finished mark to be prompted for the finished value. You could also have things such as for example, a capacitor. If you were doing some small electrical work in there, you wanted to go ahead and drop in a capacitor or a resistor, you could actually define the block, and inside that block, you would put an annotation for text that would be prompted. There's an option for retrieve. What the retrieve dimensions will allow you to do is basically import the model dimensions. That would be the driving dimensions for the model. This gets a little bit more involved. The general dimensions that you would be adding to your drawings are not bidirectional. In other words, you cannot edit that value and expect the model to update. The only way you can do that is through what we call a retrieve dimension. You can go ahead and retrieve model dimensions, place them in your drawing views, and then if you wanted to control the model dimensions in the IDW, you could go ahead and you can modify those retrieved dimensions. There's also a single sketch if there was some type of a view or just some geometry you want to quickly throw together. Maybe it was a general view that you use, whether for maybe a standard operation. Basically, you can create a sketch that has this view and you can insert it when needed. There's also options to create table. This is a unique set of columns and rows, almost like an intro to Excel inside of your IDW or DWG file. Just some information around the dimension options. As you start to work with your drawings, your dimensions would require unique styles, and at the UI and the dialog boxes, or the screenshots that you see at the top, annotate. This is just the area where you would see your dimensions. And if you, for example, may want a dimension style with 2 places, maybe you want a dimension style with 3 places with a symmetrical tolerance, maybe you want a 4th place dimension decimal place with a deviant, an upper +4 and a -2, any type of look that these dimensions would have, you're better off creating dimension styles. That way you can quickly flip between the styles. You can kind of see the looks in the dialog, the screenshot in the lower left. I have a diameter of 4 places, a diameter of 2 places, then I have a linear dimension with a ±5. These are all different dimension styles. And you can create these through the Manage tab, the Styles Editor and Standard. You can create as many dimension styles in here. The suggestion I would have is that think about what you most commonly use, and you would basically create these in your template. Once they're created and you start with a template file, these are already in there and no need to continue to create. You can always delete these and then add them back in if need be. Talking a little bit about the retrieve model dimensions. I was mentioning this a few slides ago. If you go into a drawing view, once you place a drawing view, it will allow you to get the model dimensions through the right-click menu over the view, or you could select it in the ribbon menu. You could see that in the retrieve model dimensions. And when again, if you do try to do this, a dialog box will come up and it will have all of the dimensions associated to the view that's placed. In other words, you won't see all of them. It's just going to be referenced to the view that you're looking at. And then you basically have to go in and select the dimensions. And it's kind of hard to see on the screenshot on the lower right, but you could see the green circles at the very bottom. These dimensions are displayed basically right on top of the line geometry. So once you retrieve them and you say okay, you can basically drag them out with a left click and hold in the drawing view itself and reorient them. And just expanding on it a little bit more, the screenshots on the left side show the model. And what I was just trying to show you here is in the view that is placed, I have right-clicked and basically said I want to save the overall dimensions to this block. One's listed in blue. I basically am selecting the tall vertical one, and in the very top, you can see the horizontal dimension. That would be chosen too. And when those are chosen and you come back out, if you were to double click on those dimensions in your IDW, you can actually change the value of them. It would then drive the model on the back end. So just be something to be aware of. You may or may not like this feature. If you do, you got to be careful using it. And if you work with a team, you want to make sure that this team knows, about this command. And if you're using it, you just don't want them to double click on something, change it, and realize that they're not changing the model in the background. It's a nice feature. You definitely want to take your time and explore this to see if it's right for you. All right, and that I'll just flip over to my Inventor and go over just some of the areas that I spoke of. All right, I'll go ahead and close. I'll close this file here because don't need to look at this one. I'll just open up this faceplate file, and this is the one you could see in the screenshot. What I've done here is I've actually retrieved these two dimensions. If I choose to right click over dimensions, say edit, it springs up like the edit dialog box. But it actually would be edit model dimension. So you could actually see that I'm calling up to modify the width of this file. So again, if I say here and I go 1.5, oh, so this is a bad file to pick. So I have some iMates on here and it's not failed. What I'll cancel it. What would have happened is I would have gone back to the faceplate here, and this would have actually gone and modified this extrusion value right there. It would have actually pushed this out another inch and made it 1.5. So again, that's a little bit with retrieve dimensions. Again, if I right click over the view, you can go to retrieve model dimensions, or I'll hit escape and clear this out. In the annotate tab, there's the retrieve model dimensions. Same dialog box. Once I pick the view, all the modeling views, the model dimensions come up, And this is where, you highlight the one you want to keep, you say okay, and now you have a model dimension here. Again, completely allows you to modify this. And going through the annotate tab, again, this is where just the general dimensions are. The command here, the general dimension, allows you to pick on a line or pick points. Pretty straightforward. And then there's some options for some of the chain or baseline or ordinate dimensioning. Some information here for your hole and thread notes, leader and text. I mean, everything is in here that will allow you to put in the necessary annotation that you want for the file. And the other area that I was talking about is in the Manage tab. This is where your styles and standards editor are. And if I click on my styles, this dialog box pops up, and you can see that there is a section for dimensions. By default, it gives you some general dimension styles to choose from. But you can basically right-click, say New Style, copying it from the ANSI default, or if you had an architectural, you said New Style, it would copy it from the architectural. So it depends on which one you right-click over. And I could come in here and say, to PL for a simple two-place. It creates it, and then you got to go in here and, there's my two-place style. I'll set the alternate units. I don't have any alternate units set on here, so I'll leave it as is. Different display options. I can set all kinds of different type of information in here, which you simply go back in, and then now you have the two-place. If I set up another one real quick, and I'll just say three-place. I'll set my position to 3 places. What's nice is as you come in and you put your dimensions in, you can highlight that dimension. Sorry, I'm having a problem here. There we go. And what I wasn't doing, I wasn't actually exiting out of command. So I'm actually out of placing the dimensions. And if I just select it, like pre-select it, over here is where you see the format option. And you can actually just quickly tell it, now I want it to be 3 places. So it's a nice, once you develop your dimension styles, it's a nice way to come over here and just quickly reset the ones that you want. And that's about a little bit on the annotation information. I know it's not a lot, but I do have some other info that I'd like to go through. So I'm going to go ahead and slide back over to the PowerPoint. And we'll take a little bit of information and talk about the parts list. Again, this is basically an extension of a table. In the table area, you do have parts list, but there's also a general table. It's a little bit different. Obviously, the parts list isn't more of an intelligent table where it'll work with your assembly files. So when you place the top level assembly view, the base view on your IDW, your parts list will simply want you to pick a view. And once you pick that base view, it will start to populate and get through custom properties and already fields that were populated. It will generate the parts list. Now, again, this is something that is completely customizable. You can have custom columns in there. You could have custom information driven to all of those parts. For example, maybe there was a paint spec that you wanted on each one of your parts. Now that's something that's not common in Inventor. But what you can do is you create something called iProperty. That iProperty could be defined in your part file template. So whenever you define new part files, this new iProperty called part spec may need you to fill out. Maybe it's a black, some type of code or whatever the color code is. If you do this for every part files and you come into your IDW template and you modify a parts list that includes that new custom iProperty. So if your iProperties are all filled out and you get this new assembly file in and you go ahead and populate the parts list, you'll actually get that new column to fill out with all that new information that you tagged to it. So it is kind of an interesting thing that you can customize, but again, it's strictly for assembly files, assembly information, and it's just part of a different manner to document this. And again, the table is extremely similar. It is basically just a way you can generate an X and Y table, and you can manually go in there and put information in. It is not going to intelligently pick up on selecting a view. This is just strictly a 2D table that's being put out. You can control with manual text edits. It's the same area where your parts list is located. And again, another area where you can completely customize is your text. Basically the same type of information on the annotate toolbar. You'll see the text options, whether you want it with a leader or without a leader. If you have different text formats, different text heights, you can have colors, justifications. Not sure how many text styles you may need, but again, there's no limit to them. These also can be pulled into your note text as long as a labeled text. Creating text objects, depending on how you want to define it. If you had standard notes, you could again put this in your standard IDW or DWG template. You can also type in text that is going to pull in model parameters. If you needed to call in a certain XY height or what, the text dialog box can drive the information from iProperties or from other sources. And just expanding on the annotation, the text options, you can see that there are stacking capabilities. Your title blocks are made up of text and basically sketched lines and information in there. You can include bitmap images. There's a lot of ways you can basically create a title block that is separate. Inventor handles the title blocks and borders separately, where before, if you had some AutoCAD experience, more than likely you created these as one. Inventor handles them as two separate objects. Again, talking about the custom paint spec that I was mentioning in the earlier slide, in the lower right-hand column, lower left, you will see the create custom iProperties be pulled into text fields. So this is the iProperties inside the part or the assembly file that you can basically create a text value in here, and that could be driven into the text item. And also text can be used with the sketched objects inside the Inventor. Maybe you had a finished symbol. I mentioned this before, where you wanted a piece of text to call out the finish on it, whether it was 63, 32, 125. This text would have a prompted value entry into it. Okay, I'll just flip to my Inventor here and just kind of briefly show you the text area. Again, looking over onto the annotate, there's the dialog boxes that I was talking about. You select text, you go ahead and you pick a point, and this box comes up as you could start to type. So I'll go ahead and kind of type in here. So what I can do here is now take a look at what I want to fill out. So my cursor is over here, and I can actually come in here and say, I want model properties, and I want, what do I want here? File name. So I click file name. I've got my parameter is called faceplate, and what you have to do is you have to come in here and basically either insert it, and I'm actually inserting, see how this is kind of confusing, but faceplate parameters D0, which was a dimensions, just got inserted, but that wasn't the one I wanted. I picked the wrong icon. You can see the parameter down here. There's the insert for that. But up here, I can go ahead and select and push in the file name. So you just got to be careful of which item you want to put in the text parameter, or you're looking to put in the dimension value. A little bit confusing, but if I say okay, you see how it comes out, and it's pulling in the faceplate1.ipt. Oh, sorry, I got to cancel out of this. I'll just move this out. So again, there's just a lot of things you could talk about. It's basically the same. I don't have a parts list here. I'm not in an assembly file. Here's where you could set a general column of 10 and 10. A little bit on the big side, but then again, you can see you get complete modification of what you want to model, modify this. Basically breaks you into the Excel look. Pretty straightforward. Again, just kind of playing around with it. Don't be afraid to go into the help. I'm going to go ahead and switch back to PowerPoint here. Let's see what we got up. Title blocks. So the title blocks a little bit, again, talking a little bit more about the sketched object. The title block is nothing more than a sketched object. If you could think about what makes up a title block, there's just a series of lines and then a series of text. And then it really, what it comes down to is, what information you want to pull in there. Now, you may have several different companies that you do work for, and maybe you're delivering them on different formats. Well, this is where you could create different title blocks for the 3 different customers. And the title blocks can be inserted through the drawing resources folder. And again, I'll show you that in a minute. But you can only have one title block inserted in one file. So if you try to go insert another title block, it will ask you to delete the existing one before you go ahead and put in the new title block. In the lower left-hand corner, it is a sketched object. You basically would define the title block, and in this level, you can kind of see that there's a bunch of parameters were added in there. And it's kind of cluttered as far as dimensions, but you could see somebody had started out with a simple rectangle, just drew a bunch of lines in there and then dimensioned them to make it look more precise. Overall it's 7 3/4 by 2.5, and then you got 3/8 parameter in there, and it's spacing every block out. There is text in there, and there's also prompted entries to be popped in. There's also a lot of iProperties being called for. And again, I'll show you that here in a second. Over in the lower right-hand corner, you just basically see that there's the drawing resources folder. And then you have the sheet information underneath that. And once you insert the title block, it will then appear under the sheet. And in order to modify that definition, you can right-click, edit the definition. You can right-click and delete it if you want to reinsert another one. But it's pretty straightforward, very customizable. You can put a bitmap image in there if you need a company logo inside the title block. Again, this is something I would recommend you saving into your templates, whether you have 1, 2, or 3 that you may use, or how many you may use. You save them in there, and you'll have easy access to quickly insert the ones you want. The borders are pretty much the same. I don't see a lot of people customizing the borders, but they are. Again, it's the same process. It's a sketched object. You can have a custom border size that you want. A lot of customers will just simply use the default border, but they'll just rename the zones however they choose. But again, completely customizable. Only one can be shown on the sheet. And the next subject is really just the sketch symbols. In the drawing resources folder, again, the sketch symbols allows you to create a 2D object, I guess, is the easiest way to explain it. And if there's some text you want to put on it. So in this example, I just have a finish symbol, as you can see, defined on the left, and over on the right, you can see I've got one that's dropped in with no finish symbol, and then there's one underneath it that has a 63 finish. I'm going to go ahead and just switch over to my Inventor here real quick, and I'll show you the last part of that. I'm going to go ahead and close. I'm going to go ahead and close the part I had here. We'll save the changes. We'll go ahead and close this. And I'm going to go ahead and bring back my ARM file. And I just really want to show you here. I'm going to expand the drawing resources folder. You can see there's the default border. There's the default title blocks. You can see there's my sketch symbol, but I just have created one called test. And you can see now under the drawing sheet, you can see that there's a border and then there's a title block. So if I try to insert the border, it's going to say active sheet already contains one. You need to delete it. It's going to go the same with the title block. So you get these same messages. You can only have one on there at a time. We'll take a look at the title block here real quick. If I just right click, go to edit definition. This is what you were seeing in the dialog box. If I just double click on drawn, you can see that there's physically just the information drawn was typed in, but underneath it author. If I right click on this and say edit text, you could see that they're pulling in the drawing properties author, and they inserted that in. So drawn by, straight text, pulling an I property. Creation date of the author is being pulled in as an I property. The company name is an I property. Anything you see in these parentheses, the greater than, less than sign, those should toggle a check mark to say these are, in fact, I properties. So again, it's just a pretty straightforward sketch symbol. And you define this as a title block. Come under the title blocks, define new title blocks, the same thing as defined new symbol. So if you can kind of see the test that I have here, if I go to insert this, you can see that's the finish mark. And now I've dropped in a prompted value that I can type in 63, 125, 32. So you can see how this works. If I want to edit that symbol, you can just see that I've just got some lines drawn in here, and I've got a piece of text. It's a prompted entry, and I've inserted it. And again, pretty straightforward. It's kind of unique. A lot of flexibility here that you have with drawing annotations. And I want to thank you for joining us today or reviewing this. I hope you found some information here helpful. And there's some contact information up here on the screen if you want to reach out to us with any questions or anything in general. Please use the information on your screen. And thank you again for joining us today.